Hello, this here is my 5th exam video where I'll talk about the different kinds of mutations and their effects on proteins. To demonstrate this, I will be using a very popular video game, Among Us. Among Us consists of a group of crewmates out of which there are so-called imposters, which are different from the rest. This can be applied to mutations, as mutations can be said as nucleotide base pairs / sequences that are different from the expected, aka wild type. We are given two strands of DNA in which one reads 5' to 3' and the other reads 3' to 5'. We first have to determine which strand will be our DNA coding strand. The top strand consists of a start codon but no stop codon, whereas if we were to reverse the bottom strand and look at it from a 5' to 3' direction, we can see both start and stop codons present, and would therefore be our coding strand. In our wild type example, our DNA strand will be transcribed to give the following mRNA strand. 4 codons starting from AUG till AAG will be translated to form the 4 amino acids shown below. If we were to replace the G here with an A on our DNA strand, the same would happen on our mRNA strand. Instead of an AAG codon, an AAA codon would be translated. Both AAG and AAA encode for lysine, so we don't get a change in our amino acid sequence. This is an example of a silent mutation, since although a mutation occurs due to the swapping of a nucleotide base pair, no effect is present on the amino acid sequence. In this case, the substitution of G with an A is an example of transition, since both are purines. If a G to C transversion were to occur here on our DNA strand, an AAC codon would be translated instead of the AAG codon in the wild type. In our wild type example, AAG encodes for lysine, whereas here AAC encodes for asparagine. This is an example of a missense mutation, since one nucleotide change causes an alteration of our amino acid and can affect the function of the protein depending on the amino acid's vitality to protein function.
That's rough, buddy.
An A to T transversion here on the DNA strand would cause a UAG codon to be translated instead of the AAG codon in the wild type. In the wild type example, AAG encodes for lysine, whereas UAG is a stop codon that'll end translation. This is an example of a nonsense mutation, since one nucleotide change leads to a shorter amino acid sequence, and most likely a non-functioning protein.
That's rough, buddy.
An A to T transversion here on the DNA strand would cause a UUA codon to be translated instead of the UAA codon in the wild type. In the wild type example, UAA is a stop codon and terminates translation, whereas UUA encodes for leucine. This is an example of a read-through mutation, where as shown below there is a long amino acid sequence which results in a non-functional protein.
That's rough, buddy.
These are the references that I have used for making this video. Thank you very much.